when you're performing. Now, if the music starts getting out of sync, somebody's going to start rushing a little bit. And the people that are trying to play around that, whatever's supposed to be holding the music, the conductor, the drummer, the click track, or whatever starts moving forward, they'll start rushing a little bit. And so it's out. It's out. That's what you say when the music's out. Something's out. Or it might start dragging a little bit. So, what's the purpose of the pulse? It's to basically hold the straight line. What's the purpose of the performer? It's to interpret freely by never losing that sense of pulse, the give and take that you can do around that even pulse, but you never lose the sense of where that pulse is at. If you do, you're dead. And a group starts rushing, bass player and drummer start chasing each other, it's gone. They start dragging, it's gone. So, very important point to remember about pulse. You can measure pulse by being able to take a tempo. 1, 2, bing, bing. By following a conductor, by whether you rush or whether you drag, if you can hold the tempo. Some of the ways that you get judged about how good your pace is whether you have minor motor problems, whether you're watching, whether you're thinking, whether you're scared or nervous, whether you're lacking technical coordination, whether you're dragging if it's soft, you're rushing if it's loud, whether you're following somebody else. Always happens in a symphony, if you get the violins, they'll all start following each other, and they're not playing independently and that kind of thing. That's why we get players who play a single instrument part, they gotta be independent playing. Not paying attention. Acoustical characteristics of my instrument, sir. Not gonna cut it. And then, of course, you can always blame it on a bad conductor. Okay, accent. Accent are the elements of the parts of rhythm that emphasize a pulse or a rhythmic pattern and help it to become more prominent. Now, watch what happens here. Here's just a stale piece of rhythm that doesn't have any character to it. It sounds like this. Da 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 da. Well, let's put that into a meter signature of 4/4 time. Now we're going to get primary stresses and secondary implied stresses. It's going to go da 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 dee da 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 da. How about 3/4 times? Same rhythmic pattern. Da da dee da 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 dee da 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 da. And you sound like the same non-personality rhythm. But a pickup in 4/4 time. Da da dee da 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 dee da 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 da. I think you see what's happening. The rhythm is taking on a characteristic because of the bar line. The bar line is making all that happen. That's what's causing it to change, to stay into place. The bar line presents us with the assets of security and discipline. It's like a rallying point. But if the bar line causes the music to become truncated and stiffly performed, it's not serving its purpose anymore. Just like you have to be able to hold the rhythm, you've got to be able to play through and around the bar line so that you're holding it into its position, but it's still contributing its purpose. Here's another little example of how a shift in the bar line could change the objective interpretation of a rhythmic pattern with this well-appropriate song for this particular season. Me out to the ball game, take me out to the drive-by. Me some peanuts and cracker jacks, I don't care if I never get back for it's for the whole team if they don't win. It's a shame for it's 1, 2, 3 strikes, you're out at the old ball game. Hey. Accents are often thought of in terms of just dynamic accents, where you just hit something harder. But there are actually 9 kinds of accents. I want to introduce you to them. You got the dynamic accent, hit it harder. You got the agogic accent, play something longer. Dum bum 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 dum bum bum bum. You got a metric accent. That's like the timpani part at the beginning of the Brahms First Symphony. C minor. Bum, 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 bum. The pulse is being emphasized by the C on the timpani, so it's making a metric accent. A harmonic accent, that's a dissonance that's being played on a particular pulse. Dissonances create accents. The weight accent, of course, is created when you have more musical sounds at it. Pitch accent occurs at the highest or the lowest point of a series of pitches. So you usually hear that little accent at the top. Pattern accents occur at the point where a series of notes repeat themselves. That's one. Embellished accents, those are your trills, your vorts, your turns. That always creates a particular kind of accent. And a tone color accent is an accent that maybe a violin section is playing and you hear ding on a triangle. And that's a tone color accent. It's a different kind of accent. There aren't just dynamic accents in rhythm. There are at least 9 other kinds. All right. And the last things that we're doing here are to produce a difficult rhythmic pattern. Now, I'm going to blow this at you, and I know it will only partially register. You're going to be like, what? What? No?
We've got a whole hour.
We're good? What's it?
You've got a whole hour, you're good.
I could.
You have 1 whole hour.
Oh, really?
Yeah.
I thought it was only an hour and a half long.
You're good.
2.
Good. Okay. Well, then I don't have to rush through this, although everybody will get 2 more now if it gets to be a lot longer. You'll get more now, I'm sure. So what I'll do is I'll go through this without rushing through it, but it'll only take about another 15 minutes to get through it. And that'll be perfect, actually, I think, for the tolerance of your ability. But I'll slow down just a little bit here because this is tough stuff. And I really, really, really wanted you to get this. So I'm very relieved. I don't know how that misunderstanding occurred. I looked at my watch, I couldn't quite put it together, but that statement made it a very small one. We might even be able to get a question or two in here if anybody wants it. Not yet. This will be one of the hardest things you have to understand, and yet it'll be one of the most valuable things you'll learn all day today, other than the fact that it actually applies the thing I was talking about back there. It applies the divisions and subdivisions of a rhythmic pattern up to 9 parts, the unit counts. It goes back and applies that specifically. But here it comes, okay? Have you ever been intimidated by trying to play what's called a counter rhythm or a polyrhythm? You don't think you can do it? Well, I assure you can, because there isn't really any such thing as that. It's just a renotation of standard notation. That's all a polyrhythm is. And I think I can show you that with this example. And if you'll trust me on that, and you got it in my book, you'll see that I've renotated every polyrhythm into a standard notation. So you can read the standard notation rather than having to read the polyrhythm. Look at this counter rhythm exercise, the polyrhythm or counter rhythm exercise. What you see, and by the way, this is the way I used to start the whole lectures with this example, and you can see how much I've varied things now. You have, obviously the units are not there, but they are there at the top. They're implied. Now, what did I say the units were? The smallest practical division or subdivision of the noted rhythmic pattern or the pulse. Okay? It's that which you count. If you really look at what's there, you're going to realize that that's just a choice taken out from the 9 divisions or subdivisions of the quarter note. However complicated these rhythmic patterns will be, I'll never get past that 9 divisions or subdivisions of the quarter note. So, up there, I have in that second measure, 1 D and a 2 O lit, 3 O lit, 4 and. All right, let's go down to the pulse. On the pulse, I have 1, 2, 3, 4. Now I've got to get those 2 things coordinated. I've got to get the unit count coordinated with the pulse. In other words, the pulse, the equally spaced distances in measured time, that which you feel, has to get coordinated with another thing you don't see, but that which you count, which is the unit count. So we're going to have 1 D and a 2 O lit, 3 O lit, 4 and. Now I've got those 2 things in my mind a little bit. You'll never see it on the music, but they're always there. Now, I guess if we've got time, even having said that, just for the pure meanness of the situation here, my musician's meanness, better stop talking right there. I would like for you to perform this rhythmic pattern for me. This is the way my clinics usually start. And then I say, if everybody can perform this rhythmic pattern perfectly, there's no need for the clinic and we'll all go home. And everybody attempts to play it, I say, welcome to my clinic. So Here's what I'd like you to do. I'd like you to play the 4 quarter notes that occur in the first measure of time, and then play and count out loud with a counting system, your counting system, or mine, if you haven't memorized mine yet. The counting system you would use to clap and perform the notation in the second measure, and then just finish it up with 4 more quarter notes. So it would be something like this. 1, 2, 3, 4, 1 D and a 2, 3, 4, and 1, 2, and then I'll leave it up to you to do the middle part of that second measure. Okay, so I'll give you how many counts to count out? 2, because it only takes 2 pulses to establish the distance and time necessary to feel the speed of the piece. Okay, here we go. I'll give you 3, 4. You count out loud, you clap the rhythmic pattern, and you count out loud whatever the proper mathematical count would be in order to perform that second measure properly. Here we go. 3, of course you're going to start with the first measure. 3, 4. 1. Count out loud. 2, 3, 4. Good.
1 D and 2 O let 3 O let 4 and 1.
4 quarter notes.
2,
Now repeat.
3, 4.
Go.
1 D and 2 O let 3 O.
Go back to the first measure and start over again. Now, the reason started over didn't quite make it in that second measure. I'll give you another shot at that second measure. Just look at that second measure. How are you going to play those 3 quarter notes under a triplet? How are you going to count those 3 quarter notes under a triplet? How are you going to count and play that polyrhythmic counter rhythm figure? Okay, I'll show you the total answer in just a second, but let's go back and try it again. Here we are, beginning. 3, 4, go.
1, 2, 3, 4. 1 D and 2 O let 3 O let 4 and 1, 2, 3, 4. 1.
Now, balance try, some of you may have got it, but I couldn't hear who did in there because there were too many people that were missing. So I'm sure somebody may have got it. Here's the explanation. You have, on the second and the third count of this measure, 2 different rhythmic patterns. One rhythmic pattern is 3 quarter notes under a triplet sign. The second rhythmic pattern, although it's implied, that's the way it almost always occurs. 2 notes of the pulse occurring, which are 2 quarter notes. So look at the counter rhythm characteristics. A, 2 rhythmic patterns occur within the same period of time. That's the 3 quarter notes under the triplet and the 2 quarter notes occurring on the second and the third counts of the measure. We've got that qualification met. B, the 2 rhythmic patterns are not evenly divisible into each other. 3 is not evenly divisible into 2, 2 is not evenly divisible into 3. I might have used 5. 5 is not evenly divisible into 2, 2 is not evenly divisible into 5, okay? But 2 is evenly divisible into 4, so that wouldn't be a polyrhythm. So we've got that example. So we meet that qualification. The 2 rhythmic patterns have different numerical origins. Well, this one doesn't quite go deep into the rules because in this case, we've only got the quarter notes at the bottom. And we could say that the quarter notes are going to be maybe the 16th notes by going 2/8 notes, 4/16, but they're just quarter notes right now. But we can say something about those quarter note triplets, because if you think about it, they are triplets. They're based some way on triplets. And triplets are a different numerical origin. Remember, you go quarter to 8th note triplets, 16th notes to 9/32. That's a numerical origin going in one direction. Or you go quarter going to 2/8 notes, going to 4/16, going to 8/32. That's a different direction. Or you split the difference and you have groups of 5 or 7. So we have 2 different numerical origins. And that would show more clearly if you had actually 2 different counter rhythms, like 4/16 notes over 3/8 notes at the same time, for instance. And that would apply in the same way, just a different sound. One of the rhythmic patterns must be superimposed because it's not a natural occurring division or subdivision of the denominator of the meter signature. All right, what is the natural occurring division or subdivision of the denominator of a meter signature. Its natural division or subdivision is to cut it in half, or cut it again, or to double it, or to double it again. That's the natural division. Quarters go to eighths, go to sixteenths, go to 32nds. That's like the natural division of a measure. You're superimposing something on that if you divide it into 3 parts. So, I've got a rule set up here. It's something you may not have ever heard of. I think it would help solve the problem for you, or it'll get you started. Once it's been established that the relationship between 2 rhythmic patterns creates a counter rhythm, and we have, follow this step-by-step procedure to find the resulting LCM, or the least common multiple, between the 2 rhythmic patterns. So, let's do that. Let's see what happens. Identify the pulse notes, quarter notes, and the notes of the rhythmic pattern to be performed. 8th note triplets. All right? We have 2 notes, and we have 3 notes. Or we could have had 3 notes and 4 notes, 2 notes and 5 notes, 6 notes and 7 notes. Wouldn't matter. But we'd have 2 different groups of notes. The next thing it says is to multiply the pulse notes, okay, by the notes of the rhythmic pattern to determine the least common multiple. Well, what happens if you multiply the pulse, which is 2, times the polyrhythm, which is 3, obviously what do you get?
6.
6. Now, just think about the logic of this. You are in 4/4 time, you have 2 counts, 2 pulses of the measure, and you have 6 notes to fit into those 2 counts. You're not given a choice mathematically. There's only one kind of notation that will go in there. What kind of notes are there? This you have to know. This you have to be able to understand. You have to see this, or I couldn't go any further.
6 couplets.
That's right. An 8th note, well, 6 couplets is not quite right. That would be
2 triplets.
16th note triplets.
2 8th note triplets.
2, yeah, it's 8th note triplets. 8th note triplets. You'd have 2 groups of 3 8th notes under a triplet sign, because that's 6. So you could have, and you look above at the unit count, and you see that you have 6 8th notes under a triplet sign. That is the LCM. 2 and 3, 2 times 3 is 6, and the natural grouping of 6 notes over 2 counts in 4/4 time is 2 groups of 3 8th notes under a triplet sign. 1 olet, 2 olet, 3 olet, 4 olet. In this case, it's 1 D and 2 olet, 3 olet. All right. Now, we've established that you have 2 groups of 3. But what kind of notes do you have in the polyrhythm? They are quarter notes. So since they're quarter notes, you can't have 2 groups of 3 because you can't change the intrinsic value of a note even though it's under some sort of sign. A quarter note is still equal to 2 8th notes, but it has to be equal to 2 8th notes under the triplet sign. So you can't play 2 groups of 3 8th note triplets. You have to play 3 groups of 2 8th notes that are in triplets. I know that sounds a little weird, but if you think about it, it comes out this way. 1 olet, 2 olet. 1 olet, 2 olet. See, that's every other 8th note being performed at the point of articulation of the quarter notes. That's the LCM of 6 that gives you the point of articulation of that polyrhythm. So you could go 1 D and 2 olet, 3 olet, 4 and standard interpretation, or you could do the polyrhythmic interpretation from the LCM that's just simply re-accenting. It's just placing an accent according up to those 6 8th notes, but 3 quarter notes under the triplets. So it's got to be every other one. 1 D and 2 olet, 3 olet, 4 and. That becomes 1 D and 2 olet, 3 olet, 4 and. There's your polyrhythm. It can never be any harder than that. It just can't. Now, there could be a point that you couldn't count it fast enough. You might have to go 1 D and 2 olet, 3 olet, 4 and And that sound might have to come up into your ear of being 1 deep and go ba, 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 ba. So you would have memorized the math of it, done it so many times that you would hear the sound, because it all becomes sound again anyway. So it's 1 deep and go 2, hold that 3, hold that 4, and 1 deep and go 2, hold that 3, hold that 4, and 1 deep and go ba, 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 ba. You hear the 3 English space notes based on the sound of the rhythm. Let's go back to where you are. Now you want to go 1 D and 2, hold that 3, hold that 4, and 1 D and 2, hold that 3, hold that 4, and I'll be going 1 D and 2, hold that 3, hold that 4, and let's try it. I'll be your unit count. You are the rhythmic pattern. My foot will be the pulse. Here we go. 3 and 4 count. 3, 4, quarter notes. 1, 2, 3, 4.
1 D and 2, oh left, 3, oh left, 4, and 1,
That was much better.
2, 3,
Again, be
4.
and
1 D and 2, oh 3, oh left,
4. Second right.
1 D and 2, oh left, 3, oh left, 4, and
First attempt, I will take that. I will take that with a basic level of understanding that you see how an LCM, least common multiple, can help you reduce. Now, just an example, 2 against 5. Okay? Oh, it's too hard. It's much too hard. Can't do that. Well, what's the lowest common multiple between 2 and 5? 10. Okay? How do you normally group in a 2-4 measure 10 notes? Think back on your think on your chart back there. How would you normally group 10 notes in a 2-4 measure? Just think of my chart. 2 groups of 5. So that would be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 2 groups of 5. But you have, in that 2-4 measure, 5 eighth notes written. Well, that's not 2 groups of 5, that's 5 groups of 2. Because it's just a re-accenting. It's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I just played every other note of the 10, and I just played a 5 against 2. Probably jumped you a little bit, but the principle's the same. So I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1. And that's really 1, 2, 3, 4, 5, 1. Tap on 1 and 2. I played 5 equally spaced notes. I could have gone 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, or I could have gone 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1. There's your 5 equally spaced notes. See, that's a 2 against 5. We just did a 2 against 3. We could do 3 against 4. Dum da 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 da. Do 4 against 5. Dum da 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 da. They've all got little sayings and other things, some of them not to be known publicly, others to. Okay. Now, let's touch on another area. This is getting fun now. Okay, I'm going to enjoy this. How many people can play jazz? Oh, really? Jazz is one of the greatest mediums in all of history. Well, I'm going to show you how to play jazz in 4 steps. I promise, I will. And you'll just practice these 4 steps right here. You'll be able to play jazz. Look at this rhythm under Bell's introduction to jazz rhythms. Listen to the sound that I'm about to produce on this. Do you see the two lines of rhythm here? See the 2 eighth notes and a quarter, 2 eighth notes and an eighth note? You see that? They're other hand? A couple of head nods? Okay. All right, listen to this. 1, 2, 3, 4. Okay, does that sound like jazz? It is. Boo-da, boo-da, ba, ba-do-ba, boo-da, ba, ba, boo-da, 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 ba-ba-do-boo-da, ba. And that's some scat. So, how is that done? Look at the rules. A quarter note equals a quarter note. That means that the quarter notes played the same in jazz as it's played in any other kind of music. Look at the eighth note triplets. The eighth note triplets in jazz are played just like the eighth note triplets are played in any other kind of music. Now, if I got a jazzer out here that didn't raise his hand, you're going to get a little tight in a minute for these last rules, but you got to remember where we're at. We're starting with people who don't know anything about it. All right? Look at the next one, which is an eighth note afterbeat. An eighth note afterbeat is played on the third part of a triplet because you count jazz in triplets. So if you've got an and of 1, you're going to play it on the third part of the first count triplet. If you got an and of 3, you're going to play it on the third part of the third count triplet. Pure and simple. If you got an and count of 4, you're going to play it on the third part of the fourth count triplet. And it's no more complicated than that as far as a point of articulation. Now, sometimes you can have duration, color, articulation, phrasing, all kinds of things that make it become true jazz, and many other things. But the point of articulation rhythmically is on the third part, basically, of an eighth note afterbeat. So that would be the first measure. I have 1 and 2, 3 and 4. But if I count the measure in triplets, it's 1 O-let, 2 O-let, 3 O-let, 4 O-let. 1 O-let, 2 O-let, 3 O-let, 4 O-let. Ba-boo-da, ba-boo-da. 1 O-let, 2 O-let, 3 O-let, 4 O-let. Da-boo-da, da-boo-da. That's the jazz sound. Now, look at the second measure. This is the only one that people have the most trouble with when they're trying to see it, just see it in sight. Any note occurring on an and count, so that first eighth note afterbeat is on an and count of 2. Any note occurring on an and count is played on the third part of that count triplet. So if it's on an and count of 2, it's got to be played on the second count's, sorry, it's got to be played on the third part of the second count's triplet. So it's not 2 and, it's 2 O-let. So it's like this. 1 and 2 and becomes 1 O-let, 2 O-let. Now, the next note is on 3, but the next note is on the and of 3. So it can't be played on the and of 3. It's got to be played on the third part of the third count's triplet because it's on an and beat. Anything that's on an and beat, for whatever account it occurs, is played on the third part of that count's triplet. I mean, that's what it reduces to. I can reduce it to that. I don't care if it's the duration I'm trying to deal with when I'm talking about this other. But any note that's on an and count is on the third part of that count's triplet. So look at it this way in the second measure. It's on the and of 2, I'm going to make it on the third part of the second count's triplet. 1 O-let, 2 O-let. And then the next one's on the and of 3, I'm going to make it on the third part of the third count's triplet. 3 O-let, 4 O-let. That measure becomes 1 O-let, 2 O-let, 3 O-let, 4 O-let. 1 O-let, 2 O-let, 3 O-let, 4 O-let. Ba, ba-do, ba. And believe me, that's it. Okay, so you got this. 1 O-let, 2 O-let, 3 O-let, 4 O-let. 1 O-let, 2 O-let, 3 O-let, 4 O-let. 1 O-let, 2 O-let, 3 O-let, 4 O-let. 1 O-let, 2 O-let, 3 O-let. 1 O-let, 2 O-let, 3 O-let, 4 O-let. 1 O-let, 2 O-let, 3 O-let, 4 O-let. Now, if you could make your mind see the eighth notes as eighth note triplets, and any and count just becomes the last note of a triplet for that count, you can do the jazz. I'm going to take a chance to try it with you really slow. I'll really guide you. You just try your best. You'll get the 2 eighth notes in a row, and then try to see what count that other notes are coming on and put it on the third part of that count's triplet. At least just tell me some way and nod if you at least understand the principle, then I can turn it over to you. Because you'll really get hard to say what I'm going to do next. Okay, here we go. 2, 3, 4. 1 O-let, 2 O-let, 3 O-let, 4 O-let. 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 O-let, 2 O-let, 3 O-let, 4 O-let. Now ask, please ask. Ask. What don't you understand? What measure couldn't you play? What do I need to say again? Anybody? What measure do you not understand? What couldn't you do? Which measure do you want to hear again, or you want me to re-explain?
Second measure.
Second measure? Okay. On the second measure, I'll go back to the fourth rule, which is D. And it says any note occurring on the and count equals the third part of that count's triple. All right? In the second measure, the second note occurs on the and count of 2. Therefore, it has to be played on the third part of the second count's triple. 1 olet, 2 olet.